Okay, here are the free response answers for the Chapter 8 test. So we'll take a look at question 1 about zoologists, and let's see which animal was this. Female kangaroo rats. Okay, I've actually changed it several times. There is such a thing as a kangaroo rat, by the way. You can look it up. So the probability that one of these kangaroo rats will be resting is 0.18. Okay, and I guess we're going to look at x as the number of kangaroo rats out of some fixed number n that are resting at any given time. Okay, what distribution does x have? Well, that is going to be obviously binomial, because we have the 4 characteristics. We have success or failure, and here a failure or a success is going to be if they're resting. Okay, we have a fixed number of trials, so fixed n, because that's given in the problem. Right here, fixed number n. And then probabilities are the same, and probability is independent from kangaroo rat to kangaroo rat. Okay, and we have to assume those last two actually. But that's okay. If you made a note of it, great. If you didn't, that's fine. But binomial, what I was looking for is that you stated the 4 characteristics. Okay, so now if we scroll this up a bit, in a random sample of 20 female kangaroo rats, what's the probability that at least 15 will be resting at any given time? Well, n is equal to 20, p is equal to 0.8, because that's the probability of success. And so we're looking at least 15. So greater than or equal to 15. And I expect everybody will have done this. Let's put a 14 in there, 16 up to 20. So at least 15 is going to be this. Okay, we can't do a CDF function with that, but we can with what's left over. So we're going to go ahead and make that 1 minus the probability that x is less than or equal to 14. Guys, this is the work. The calculator speak is not, and the only reason I'm going to write it here is so you know what I'm doing on the calculator. But remember, if it's in red, you do not put it on your paper. Binom CDF of 20, 0.8, and 14. And once you do those computations, you end up getting 0.8042. 0.8042, like that. Okay, and then if we scroll it up a bit, like that, in the same random sample described above, what's the probability that fewer than 10 will be resting? Okay, well now we're looking at 2, 3, 9, 10, 11, up to 20. Fewer than 10. Guys, be really careful about this. I saw a lot of people making the same mistake. This is the probability that x is less than 10. 10 is not included here. So if I rewrite it so we have an inequality with an equals in it, we can rewrite it like that. Now this is just a straight CDF function. So let me change that to red. A binom CDF of 20, 0.8, and 9. And that probability ends up being, I'll flip the page here. Let's see, my calculator says 5.634 times 10 to the negative 4th. Some people are still putting e negative 4 here like the calculator says. Don't do that. That's calculator speak. Okay, it needs to be written in scientific notation like that. Okay, now we'll move to question 2. So this is the same idea as what we needed to do in question 1. Prove that x has a binomial distribution. Again, you just show the 4 characteristics are true, and you've shown that it's binomial. Okay, now they tell us that no pesticides at all, that's a success, were found in 65% of a sample of domestically produced foods. So P is equal to 0.65. N is equal to 20, because they tell us that right here. And so mu is NP, which is equal to 13. Sigma is the square root of NP times 1 minus P, And when you plug all that in the calculator, you get 2.133. And so that's sigma. Those are the easy questions. Okay? Based on a sample of 20 food items, is it likely you would observe less than half? Be careful, guys. Less than half is the probability that x is less than or equal to 9. Okay, half is 10. It says less than half. So 10 should not be included here. And if we do our little diagram here, 9, 10, 11, up to 20, we're looking at this probability right here. So, using the calculator, binom CDF of 20, 0.65, and 9. And with that, we get 5.3%. It's 0.053 or 5.3%. All right, question number 3. Obviously, this question is just a few years old, since I still have Khalil, a well-known baseball player. Finished last season with a .325 batting average, so his probability of success getting a hit is going to be 325. What is the probability it takes him more than 4 at-bats to get his first hit? What kind of distribution is that? Yes, you're right, it's geometric. So, we are looking for the probability that x is greater than 4. More than 4, so no equals here. So we can change that, make it look like greater than or equal to 5. And I'll just draw my diagram out here so you can see it. More than 4 means 5 or more. Okay, can't do this with the CDF function on the calculator, but I can do this. So we'll do 1 minus the probability that x is less than or equal to 4, which is 1 minus, and then I use the binom, or the geometric CDF, I mean. So geometric CDF, let's see, probability of success is 325 and 4, and with that I end up getting 0.2076. 0.2076. And then the expected number of at-bats he will need to get his first hit of the season. All right, that's the mean. Okay, expected number, remember average or mean. Mu is equal to 1 over p. So that's equal to 1 over 0.325, which is equal to 3.077. Do not round that. If you round it, you're going to get dinged probably 2 points on this, I think, is what I did. So on average, it will take 3.077 at-bats for Khalil to get his first hit of the season. And there you go. So one thing I'm going to add on here too, in question 2, let me back up just for a second because I failed to explain the answer here. Based on a sample of 20 food items, I found the probability, okay, of finding less than half without any pesticide. The explain part I didn't do, and I dinged you guys for it, so as I went back and looked at my answers, I caught that. Okay, explain. Since the probability is 5.3% that we would observe less than half, you can actually go both ways on this. Is it likely? If you think that 5.3% isn't often enough, about 1 in 20 times, then you would say no, it's not likely you would observe less than half. If you thought that it was likely, that 1 out of 20 was likely enough, then you could say it was. But that's the explanation that we're looking for, just a justification of if 5.3% you think is high enough to say it's likely to observe less than half without any trace of pesticides. Okay, and we'll go back here and just make sure I caught the rest of it too. Yeah, I think I did, because the other ones just ask for a probability but not a justification. So, okay, cool. We're done.